Okay, so we can start our interaction. Hopefully, you have gone through some of the lecture videos that I have sent across. So, any doubt, etc., regarding those videos, you can ask me now. You can raise your hands. You can raise your hand here in MS Teams. Did you go through the videos? Many of you have not gone through the videos. I can see by the views, but some of you have definitely gone through the videos. So, is there any doubt? Is there any problem in understanding the theory? Any suggestion, any feedback regarding the way of teaching and all? Anything is welcome. Any feedback, anything you want to say? Keshav, Keshav, unmute yourself.
Yes,
Yes,
sir.
sir. Yeah.
Sir, reason for defining the alternate first companion form. We calculated so many things and what was the reason for calculating alternate first companion form? Motive.
Yeah. The as far as I remember, in the alternate in the original one, the C matrix was having the coefficients of the numerator, right? And the B matrix was like 0 0 and last one was 1.
Yes, sir.
When you make it the alternate, then all the B matrix elements, all of them become like in general they are non-zero. So it in if any particular coefficient numerator coefficient is 0, then it will also come there, reflect there, but in general they are non-zero elements. So that means each state dynamics is getting influenced by the control input. So even though the states that you had defined remained same, the states you defined remain same, but the state dynamics changed because of this. So the representation changed. So the way the states would evolve with time would differ in the original and the alternate forms.
Okay, sir. Understood.
And why we do this? And so this is basically like design and analysis things are there. So in some cases you want to understand the how the input is would affect each of the state dynamics. Sometimes you don't want that. Sometimes you want a chain of integrators sort of an expression. So in that case the original form is better suited. So I hope you understood the chain of integrators concept. Is there anyone who does not understand the chain of integrators concept? That is a very fundamental concept in modern control systems. So if you look into the phase variable form, you would find that the states are defined as like x1 dot is x2, x2 dot is x3. So it is as if the states are passed through integrators, chains of integrators, and the last one would be xn dot, which is sitting at the input of the first integrator, and output is at the output of the last integrator. So this xn dot is passing like through the all the chain of integrators, and then xn dot is getting influenced by the input in the first original SPR. So I hope it is clear. Some chats are here. How to say if we are using the minimum states required apart from the invertible A matrix? Yeah, we will come to this actually. So you hold your query a bit. We'll come to this problem when we have non-minimal representations, or actually we will understand what are minimal representations. From that you would be able to understand what are non-minimal representations. So this comes a bit later in the course. Any other query? So I hope you are all going through the lecture videos. So please go through the lecture videos as soon as they are uploaded, or at least within that weekend, so that you can pose your questions, you can clear your doubts in the next week's live sessions. Because now, like in this Thursday, Friday, the tutorial will be up for these lecture videos, the tutorial, the quizzes, etc. And you will be given around 7 to 10 days time to submit them. So I want to ask you that last week, so the tutorial was uploaded on, there was an assignment, right? That was uploaded for you guys, isn't it so?
Yes, sir.
Yeah, so the assignment as well as the quizzes are having the deadline of this Sunday, this Sunday midnight. So you are getting around 10 days of time. So is it too long a time? It is absolutely not too short. So I am not going to extend the time. But if it seems to be a bit long for the class in general, then I can also give like 7 days time, or maybe 3 or 4 days time. What do you suggest? Any
No, sir, it's
suggestions?
fine.
It's fine. I think Vipul can take a consensus. If majority agrees to this, it's fine. At least tutorial is fine, I guess. I am a bit not so comfortable with giving so long a time for the quizzes. So you can take a consensus on the quizzes, and I believe that as soon as you go through the lecture videos, you would be able to do the quizzes. So probably it shouldn't take so much time, but still if you feel that you need around 10 days to be comfortable with the topic and then answer the quiz, is fine with me. But one thing, let me tell you that if you are doing late submission, so I am not closing down the submission. So there you can actually submit late. But if you are doing late submission, that shows up in the system, and it will be very easy to understand who is doing late submission and who is not doing. So if you are doing late submission, there will be some penalty associated with it. So you will not be getting the marks as those students who are submitting within time, even if you have answered at par. So even if your answers are at par, you will not be getting the same marks if you are doing a late submission. And that same thing will also apply to the quizzes. So like in the quizzes, 50% is the cutoff marks for passing the quiz. But if you are doing a late submission, it will certainly, there will be a penalty. I will increase it a bit for the late submitters, and I have not yet decided what should be that penalty, but let me see. I hope that the quizzes will get submitted within time, because they are not very difficult. You don't worry, you take a plunge with the quizzes. Just after seeing the videos, I'm sure you will be able to score 50%. That won't be a big deal. So I hope the quizzes can be completed within time. So I can understand some of you might take a bit longer to complete an assignment, but that only, like, you are only inviting the penalty upon yourself. if you are doing that. Okay, let me answer some questions here. I am seeing some questions. Kshitij, then maybe in the case where we don't know the dynamics, but we can get the transfer function without that. But do we find the transfer function of physical? How do we find the transfer function of a physical system without knowing internal dynamics? Some part of this is already covered in your first course, I believe, where you are where we I think, at least I remember myself studying when I was studying control systems back in the days. There was so if you have a first order step response sort of a thing, then you can easily derive the first order transfer function of that system. So even so, it depends on the response that you get from the step response that you get. So by analyzing the step response, there are multiple ways of deriving the transfer function, and not just step response. There are other ways of analyzing the input and output response of a system, and you identify the system, identify the transfer function, or identify the system dynamics. So these are the identification problem, which is not directly a control system problem, but they are dealt within the purview of control systems. So these are called identification of systems. If you are interested in that, it actually forms an entire course. So there are lots of different techniques for identification. MATLAB also provides identification toolboxes. So in that, what you need to do is basically you need to provide some inputs to the system and record the outputs from the system. So it is like a black box. So now you have to predict what is the nature of the black box. So how does it behave? What is the transfer function with which you can model that behavior? So there are methods, there are techniques which will give you the transfer function. So it is outside the scope of this course to go into those techniques. There are vast lot of techniques actually. I am not an expert also in those, but a few I know, and mostly they are dealt in the, like, it is very standard techniques are there. So the identification toolbox takes care of a lot of those techniques. What is the medium of submission of tutorial and quiz? Medium of submission means, what do you mean to say by medium of submission, Urjita?
Sir, will it get submitted when we switch on the quizzes, or do we have to write it in a paper and scan and submit?
For quiz, you will see these are MCQ. Okay, so
Yes.
it is simply you choose the right answer, and at the end of it, you will have a submit button. So once you
Hmm.
press the submit button, your answers are recorded. You will not be able to access the quiz anymore. So it is only a one-time submit. But I think that if you just open the quiz, you will be able to see the questions, but unless you press the submit, it doesn't get submitted. So you can take your time to answer the questions, be confident in that, and then submit the quiz. Once submitted, it is submitted. You cannot do any changes, or you will not be able to do any changes on that. Now about the tutorial has to be handwritten. So you should make a handwritten copy of your answer sheet. So it should not be typed. Okay, so we should see a handwritten copy of the answers of the questions. So you note down the question number, or you may copy the question also. We have the question, so you can only note down the question number, that is fine. Then you write down, you solve the problem, with your hand, pen and paper. Okay,
Yes.
so you do a rough first, and then when you are done with that, you copy a fair one. The fair one, you take a scan copy, form a PDF, or you take a photo and form a series of photos. Anything is fine. Okay.
Okay, sir. And should we upload it somewhere on Teams, or should we mail it to you?
It should be uploaded in that assignment. So when you open
Okay.
the assignment, you can open the
Yes.
assignment. At the very top right, there is a turn in button. You don't press the turn in button, but you will see that the document is uploaded, which is the tutorial sheet. So you can download the tutorial sheet, and
Yes.
there is also an option to upload something. So there you upload the your assignment. So in that upload
Okay.
option, you upload your assignment. Okay, and then you
Okay, sir.
press that turn in button. So when you press the turn in button, your assignment is turned in to us for checking. Okay.
Okay, sir. Thank you.
Yeah. When do you have to upload the class notes? Class notes will also come in form of an assignment. So like the tutorial is there as in form of an assignment. So in one assignment, I will ask you to prepare the class notes from this lecture to this lecture. So normally it will form a like a module sort of a thing. So like now, I think your lecture one, all the lecture ones are over, right? So probably this week only I will ask you to I will give you the tutorial also, the next set of tutorial on the lecture 1 series, and also ask you to make the class notes of the lecture 1 complete module, lecture 1A to lecture 1E, I think. So those lectures. So then you form your class note and then you upload it in that same way. So you open that assignment, there is an upload option, you upload your scan copy or your photo. So and then you turn it in. So this is the way we would also do with the class notes. So this is about all the logistic parts. So I hope the logistics are getting clear day by day. So anything on the topics getting discussed, the SPR, state space relations. Did you uh, get an understanding why the diagonal form is important? Any queries on that? Remember that diagonalization is only possible when we know the eigenvalues of the system. And another thing is that the eigenvalues must be distinct. So these two are important criteria for diagonalize for for a system, for a SPR to be diagonalizable. Okay. If we are not having distinct eigenvalues, then what? So that is a natural question to ask. That will be get covered. Actually, we are proceeding towards that only. So the next set of lectures will cover that only. And while doing that, you will get a fair bit of understanding of the mathematics of state spaces. So the vector spaces, the mathematics of vector spaces, that is what I am covering right now. If some of you have seen the videos which were uploaded, I think yesterday or the day before, and one or two videos will also come after this, which will give you a preliminary of the linear algebra basics, as much as we need in our in the perspective, in the purview of our course, to deal with the SPRs and to understand, to analyze the SPRs and to understand the design concept, and to understand how the what the SPRs actually tell us about the system. So has anyone of you seen the math preliminary videos? Can you raise your hands who have seen the math preliminary videos? A few of you have seen, I think. You're not raising your hands, maybe. Okay, Vikram has seen, I think. Hmm. So only Vikram has seen the video. I'm sure some other people have also seen. Okay. Okay, no problem. But you go through the videos. Okay, you try to be upfront and don't keep them accumulating. Don't keep the videos accumulating. So go through the videos, go through the lectures as and when they are uploaded. Otherwise, you will see that at the end of the week or at the end of a few days, there is so much to cover. And this is also important for your quizzes, because I may say something very specific or very unique which I will give in the quizzes, and you might not find it in any book or any reference material. So it is important for you to uh, get the grades in the quizzes. Bhaskar has asked something. There are many block diagrams in the lectures. Do we need them all in detail for class notes, or just understanding them is enough? See, in class notes, you have to cover the content that I am covering in the lecture videos. So, of course, the block diagrams form a part of that content. So, they need to be there in order to have your notes also complete. And these are asked also. These are very standard block diagrams actually. So they are also asked in exams, and it is also beneficial if you remember the block diagrams. And it is not so difficult to remember the block diagrams also, but like of course if you ask me right now, I have uh, not paid that amount of motivation for me to remember. So you will have some motivation to remember the block diagrams. And when I was doing the course, I was able to remember, and there is a pattern. So you should look into that pattern, and it is fairly easy to remember. But right now if you ask me, I will not be able to reproduce like from the back of my mind. But you should be able to do that, and it is not very difficult also. But drawing them, okay, drawing them is also not difficult, purely because it doesn't take much space. If I could fit it in a slide, then you should be able to fit it in a paper. Okay, just be careful with drawing that. You can draw it with pencil probably if you need to erase or need to strike off something, if you do some mistake. Always it is good to draw things in pencil so that it is neat and clean. Okay, now since Bhaskar is interacting, I remember that only Bhaskar has uploaded something in the channel about oneself. So why are you not guys interested in getting CWS marks? So you should upload something. So you can, it is only your name, what does it mean, where from you come from, what is the interesting or unique thing in that place. So let every one of us know about your place, about a bit of yourself, and something which made an impression on you, and you learned something from that. So we can also learn something from your own your experience. So please do it. So if you keep it keep it pending, then it will actually become a burden when you are trying to do it. Right now, still not so much of pressure has come from all the courses. Assignments have not yet started maybe in all the courses. So this is the time, you take this time to just formulate that intro video. So do it by this weekend and upload it in the channel. So don't keep it pending. And also, as I already told you, your junior class has really taken a good interest in this, and many of them has uploaded the videos. So almost 50% of the class has already uploaded, and every day one or two new videos are coming in. So take that enthusiasm um, in you also, in your class also. Anything else regarding the lectures, the topics? So I guess I already uploaded up to 1E. Did I upload up to 1E or 1C? I forgot also. I'm
So one
recording.
E.
Sir,
1E. 1E I uploaded, na? That means I also covered the similarity transforms and how to derive a transfer function from a SPR. Those things are fairly easy. Deriving transfer function is very easy, and similarity transformation is the backbone of modern control system. Backbone. So in many things, what we do, we go to some state space where our analysis becomes easier, or what we want to prove, or what we want to design, the controller that we want to design can be easily designed in that particular state space realization. So we need to actually figure out that transformation which takes us to that particular realization where we can work very easily. So this forms a very basic part, fundamental part of at least in our research domain, this forms a very fundamental part, the similarity transformation. Because we get a system, it can have any structure, any like this state dynamics can have any structure, but we already know that we can design very easily for a particular type of state space realization. So now the task would be to take the original structure to this particular structure where we are comfortable in working with. So there a linking of a similarity transformation would exist, or if it exists or not, that is also a question. So normally we try to find that similarity transformation. So it forms a very important part in modern control systems analysis and design. Anything else? What was there in 1D? Was there the diagonalization and all in 1D? 1A was the introduction, 1B I think was the phase variable and rectangular form, or only the phase variable form maybe?
So dividing.
Huh?
We looked into the mechanical electric circuit.
There was a derivation from the physical systems, yeah, and the block diagram. That was part B, and then C and D were with the this transfer function to SPR, and E was SPR to transfer function, and the idea of similarity transformation was given there. Yeah. So did you also understand how these are forming, how this is related in some way to the digital electronics course? So I tried to make a parallel. They are not related as such, means they are widely different things, but there is an underlying connection. The way we have actually uh, brought out the subject, have laid down the subject, is quite similar. In digital electronics, as you see in the number systems, different representations, one representation one representation can be converted to another representation. Here also you can see that thing coming in. The different realizations, one realization can be represented, can be transformed to another realization. All the realizations giving the information, giving the knowledge about one particular physical system only. The physical system does not change. So even in the number systems, the actual value that we are talking about, the quantity we are talking about, does not change, even though there are so many representations. So this sort of parallel you can notice, and it will really fascinate you. So this sort of parallels exist in many different subjects. So if you look at the subjects carefully with this sort of a mind of looking a bit deep within, we really get fascinated. There are a lot of things that can fascinate us like this. So this actually I noticed when I was preparing the lecture videos. So it didn't occur to me before that. So you can understand that this sort of revelations can happen anytime to anyone. So there is nothing very novel or anything like that, but this is some discovery that makes you happy and also like fascinates you. Okay. Uh, so I didn't look at, even though I was dealing with SPRs for such a long time, but and similarly transformations, but I didn't have that. This thought didn't come to me anytime that they are so much related to the number systems representations in the same way as the number systems are related, SPRs are also related in similar fashion. So this thought never came to me. It only came when I was making the videos. And on spot it actually came, and then at that spot only I talked about it. So you may have heard it in one of the videos in the 1E, I think. So when you keep looking at something and you keep dealing with something, then more and more knowledge actually you can derive from that particular topic or the particular set of information. So all these which you are getting are basically set of information. So as in the digital electronics course also I try to highlight about the difference between information and knowledge. So we are getting this set of information. As more and more we look at it, more and more we spend time with it, the inner knowledge actually we can extract. It automatically comes to us, but we have to spend time with it. That's all. Some chat has come here. Okay. Anything to ask? Anything to discuss? You go through the math preliminary videos. I'm sure there will be a lot of confusion, and I'll be happy to clear those confusion. So, and I'm sure that as I got some um, comments in the last lecture or last live session or so about your math math course that you had where linear algebra was taught. So when you are looking at the linear algebra the way I present it, there might be some confusion or there might be some clarity also, but you have to develop, you have to get clear on these concepts. I try to deliver it in a way that you will be able to grasp the real meaning of how we use it in control systems, in the purview of control system. I'm trying to target it in that direction. So probably you will at least find a meaning of the maths. Maths only by doing the mathematical computations, following the algorithms does not mean anything unless, at least to us, at least to engineers, it doesn't mean anything unless we see how it actually works in a real system, how those computations are how those computations hold some meaning in a real environment, in a real system. Linear algebra is vast. Vast means it has vast applications. Linear algebra is one. If you have to learn one mathematical topic very well, that should be uh, two mathematical topics. One should be linear algebra, another should be differential equations. These two one has to learn very well as engineers, because both these are you can see these two mathematical what should I say, mathematical topics or mathematical subjects. Both these mathematical subjects will appear anywhere you go in your life, if you are going in advanced academics as well as in advanced um, industrial level also. These mathematics will come into picture. In communication technology, which is a huge market, there is a huge market for communication technologies. Linear algebra has a wide role to play. Someone has asked some question. Some pop-up was there. Okay. So if there is nothing else that you want to ask, then I want to actually talk about something which is unrelated to this subject. So I want to point out some fact and for your observation and for your curiosity. So you know what is breathing rate? Breathing rate is the number of breaths we take per minute. One breath is basically one inhalation and an exhalation. So paired together is a complete breath. The next inhalation you start is the next breath. So how many breaths we are taking per minute is our breathing rate. So I ask you to look into this fact that which animals are having what breathing rate. You can simply search breathing rate of maybe a tiger or something like that. In Google you can do a search, but I want you to at least look into these few animals, and you can look for other animals also. Look for cat and dog, look for a human being, and look for a tortoise or turtle. Why I am talking about these animals only? Because they are very well known to us, these animals. And we know one fact about these animals is that the cat and dog lives for a span of around 15-16 years, not more than that. Human beings live for around 80 or 90 maybe nowadays. And how much does a tortoise live? They can live up to 200 years or even more. Correct. So I want you to look into the breathing rates of these animals, and you may probably have some sort of a revelation or something like that, to note the breathing rate and relate it to the lifespan of that creature, how long it lives. So normally we may have no idea about the relationship between breathing rates and lifespan, but if you look into these animals, you will find that cat and dog have a higher breathing rate than humans, and turtles and these creatures, tortoise, they have very low breathing rate. So they take around 2 to 4 breaths per minute. So this gives you some perspective about breathing rates and lifespan of creatures. So you look into very many different animals, you look into their lifespan also, their average lifespan, breathing rate and the average lifespan, and some data will be collected, and you can you can have a analysis on that data, and in the next live session we can discuss on this more, when you have figured this out, when you have found something about this. Okay, so start making your videos at least. Okay, so that is one thing important. Yeah, so Kshitij has already googled and gave you the answer. Kushi has said that breathing rate should be slower. Athletes have slower breathing rate, healthier lifestyle. Very true. They will Vimal, more breathing rate, less lifespan. Very true. Cold-blooded animals have lower breathing rate because they need to conserve heat. Okay, Jayati has remarked this. This I did not know so much, so this is one information. Cold-blooded animals. Okay, so you also look into this fact. Other people also look into this fact, and whatever information we can gather, we could gather. We can have a discussion on this in the next live session, and I will point you out to some facts or some things which might help you in understanding yourself better. So with this, I guess we can end the lecture, end this live session. It's not really a lecture, so in this live session. Okay, some hands have been raised. Shivam,
Sir, actually, I have inboxed a doubt that I'm facing.
sorry, sorry,
Sir, I have inboxed a doubt.
inboxed in my chat. Okay,
Yes,
let
sir.
let me see. How to solve problems in which x1 and x2 are incorporated in between the block diagram, and then asked to find the state representation with some combination of x1 and x2 as a state vector. I am not able to understand your question. What do you mean by incorporated in between the block diagram? Okay, so in the block diagram, incorporate in between the block diagram, in between the block diagram of what? Like in between which block of the block diagram?
Sir, like before 1 by x1 is written there, and after some distance x2 is there
Hmm. So those particular
with US and
signals.
CS.
So if it is already specified where your x1 and x2 are, if it is already specified, then that particular signal is your x1 and that particular signal is your x2. Then you have to see mostly these x1 and x2 will be at the output of an integrator, because otherwise you will not get an x1 dot anywhere. Okay, so just before that integrator you will find x1 dot if the output is x1, and then you can see what is x1 dot comprised of. The x1 dot would be an output of a node, and what are the signals coming into the node that will comprise to give you x1. How to find state space representation with some combination of x1 x. Okay, then you are saying that if x1 and x2 is already specified, then how to find the state representation with some combination of x1 and x2 as a state vector. So suppose you want z1 as x1 plus x2 and z2 as x1 minus x2 probably. So then how to go about with it? That you are asking, right?
Yes, sir.
Hmm. So then what you do, you take your z1 as x1 plus x2, you take your z2 as maybe x1 minus x2, then z1 dot is x1 dot plus x2 dot. Now you look at the state diagram, the block diagram. From the block diagram you will be able to see what is x1 dot and what is x2 dot. Do you understand?
And sir, if in case there is no integrator present in the block diagram, then
If there are no integrator present in the block diagram, then it is not a dynamic situation. integrator has to be present. Ravi, I think your Ravi Raj, please mute your mic. I can mute all. Okay, so Shivam, what I was saying, and for all of you, so if you see there are no integrators in the block diagram, then you are not having a dynamical system. A dynamical system means you must have an ODE, that is the dynamics. So something is changing. The information of change is given to you by the dx/dt only. So unless you do a ddt of some signal, you are not getting the information about the change of that signal. And unless there is a change, you don't use the word dynamics. It is statics then. So when there is no change, it is a static system. When there is a change, it is a dynamic system. So the dynamics will come into picture only when you can get a x dot sort of a situation. And that x dot will only come from a block diagram when you have an integrator present in the block diagram. Otherwise, there is no way that a x dot can come. Of course, if a differentiation block is present, then also it can come, but in normally we are not using the differentiation block in the block diagram. We are using gain blocks, integrator blocks, and summer blocks. These are the basic components. So in the integrator block is actually the cause of giving rise to that dynamical equation. Okay.
Okay, sir. Thank you.
Harshit, you are trying to say something about no, Shivam is saying it is because of heartbeat and not breathing rate. What is because of heartbeat and not breathing rate? Shivam, can you clarify? Shivam Kumar. Now Shivam Kumar is silent. So has remarked something, it is because of heartbeat and not breathing rate. What is because of heartbeat and not breathing rate? That I am not able to understand.
He's saying about the cold-blooded animals. He's saying about the lifespan, I guess.
The cold-blooded animals have lower breathing rate because they need to conserve heat. That Jayati has commented. And he is saying it is because of heartbeat and not breathing rate. The conservation of heat. That's what you are trying to say. Okay, Shivam is saying the animals with slower pulse rate tends to live more like turtles. Okay, so slower pulse rate means the heartbeat. That is true, not the breathing rate. That is true, but is there any occasion where we are having a low breathing rate and a higher heartbeat, and lower heartbeat and a higher breathing rate? uh, is that sort of a situation comes for any organism, any living being? You can have to check it out. I don't know for sure. Okay, so there are a lot of discussion is happening. Harshit is saying, yeah, almost like a machine which walks faster, braking earlier. Yeah, quite true. So actually, there is a saying that so you might not have come across this saying, but there is a saying that the total number of breaths that we have in our lifespan is fixed. So it is not a like firmly grounded fact. but just a way of saying that the total number of breaths that we have in our life is fixed. So if you complete that in a less number of time, in a lesser time, then your lifespan will end earlier. So that is the meaning of it actually. So it actually means that the lesser breathing rate that you can maintain in your life, you can increase your lifespan. That is what it means. Smokers take more number of shorter breaths. Okay. So anyway, we'll end the discussion here and we'll carry on with the discussion in the next live session, which is in Thursday. In between, you go into the mathematical preliminaries videos, because I am sure that there will be a lot of like there can be a lot of clarifications needed, and I'd be happy to clarify those doubts, and it might take a bit longer than even 2 sessions. Maybe I'm not very sure. You may be smarter than how I uh, what I feel. So I'm judging on my own reference frame. So it might take you some more time. Some of you might take lesser time. So it is entirely person to person. It will vary. So start looking at into the maths. Whatever doubts come up, we can have a discussion on them in the next conversation. Okay, so I will end the lecture now, and thank you for your attention.